that's just as powerful, if not more powerful, but we'll ask you. So, we now need a test statistic and a p-value. Both of these will come via technology then, since you don't want to do Excel spreadsheets. Good for you. So, let's slide over here. Let's get this guy turned on. Thank you, Linda, for making the connection between a two-tailed test and a confidence interval, and Veronica as well. We're going to see that connection right now. Don't you worry. Don't you worry. That's because you're looking at 1986 technology. This is the era of Pac-Man right here, my friend. Waka, waka, waka. So, we're still doing one prop Z test. Choice 5, one prop Z test. Stat tests. One prop Z. Selected. Now, mine pulled the data in. I do have to fix a few things. I've got to fix my P naught, which is now 0.135, yes? My X and N are actually correct because it carried those numbers over from that last confidence interval calculation I did. So 121 out of 710. That next line, prop. I got 3 choices, yes? 1, 2, 3. First one, yes? It's got to be the first one because we're doing a two-tailed test. Thank you, brothers and sisters.
So
two-tailed test.
On our cheat sheet, should we, if this is different, that we should have it?
Absolutely, and I'm going to use that word as clear as day. Different, different, different. I like using that
And
word.
if it's less, then it's the alligator being reviewed.
Yeah, I don't want the alligator analogy. I don't know how to understand that. So, Catholic school, I got the alligator beaten out of me. Sister Grace. Ready? Now, you can hit calculate versus draw. I like to just hit draw, though, because it gives you the 2 things you need, the test statistic and the p-value. Let's do it. Here goes! Linda's concern was that she saw no shading. But good. The thing is, there is shading. It's just the resolution is so crappy on your screen, and it's look at the numbers.
0, 0.
Yes, look at the numbers. Your test statistic is positive 2.7621. That's 2.7 standard deviation. Good. And Veronica, her eyes go right over to here. She goes right over to here, and she goes, where is that? Now, you can't tell where the actual percentage is. You can't tell what the percentage is, but you could divide 121 by 710 to get that, couldn't you? If you wanted to. You could divide 121 by 17 to get that, yes. P-hat. But you know you're 2.7 standard deviations away from this one, don't you? And you're positive. You're at positive. 2.7621 Z equals. The area that's actually being shaded, however, believe it or not, is not just this one, but it's that one plus the parallel area on the other side. Because you went into the test, going, I don't know if it makes it better or worse, I'm going to check them both. You check them both. And that's the, look at your p-value, 0.0057. That's like a half of 1%, yes? That's pretty little, yes?
Yeah.
It's pretty little. So what do we think? Do we think we're on this curve? Do we think we're on this curve? No, I think we're on a different curve. I think we're on a different curve. We'll come back to that too. Come back to that too. So now let's continue. Let's continue. We've got our test statistic. Make sure you put a Z on there. Well, dock you points for forgetting test statistic variables.
Plus and minus.
You don't have to put plus or minus. Tradition says you just put whatever sign it has.
Okay.
Now, Jolene brings up a good point. She's like, dude, it's positive 2.76. Doesn't this say that it's worse using Prevnar? Well, yeah, but we figured that out from the confidence interval, right? But the standard hypothesis test, as Linda said, we're doing 2 areas. It takes that one and makes it plus or minus. You don't have to write it though, unless you want to. You can totally, I won't dock your points if you do. So the p-value, go ahead, Linda.
So you put the...
You don't have to put it down. Just write down the test statistic. The technology immediately also drops it here and shades both ways. So essentially, it'll be double the p-value for a 2-tailed test than it is for a 1-tailed test. And again, the reason is, when you're going into a test, you don't know what's going to happen with these differences. You're just saying it's different. You don't know if it's higher or lower. So you just pick them both, and it tests them both simultaneously. Tests them both simultaneously. Yeah, please.
So that would be negative
0.7621, yeah. And Jolene asked the question, can I put plus or minus? Of course you can if you want to. Just the TI won't and the research won't. You have a problem with it though. It's like the plus or minus with the confidence interval in that respect. Okay, shall we? Number 9. Either appears or it does not appear. Try it right now. Try it right now. Circle either appears or does not appear and try to finish the conclusion. What was the point of the study? To get to this, to get to step 9 was the point of the study. Your guys' job? Conclude. Yeah, conclude. That was right.
I don't know why I'm having a hard time.
Because it's somewhat illogical. You're seeing a positive 2.7, and your mind's saying it's worse than the competing medicine. Right?
It's worse, but then it's better because you're in both sides.
But it's not that it's... Your data fell here. So Prevnar shows itself that it's worse. But when you run a two-tailed test, you allow for the possibility of this. Can I answer this question in a way, regroups? I want to, this is a very, very, it's good that you're wrestling with this. A two-tailed test isn't always super logical. Let's synopsize in a minute, if that's okay. Give me a conclusion.
It appears it changed.
Give me a little bit more than that, Em. I love that. Give me a few more words. Did you hear what Emily said? She said it appears it changed. Awesome. Define the improper, define that pronoun for me and define the word change a little bit more.
It appears that Prevnar has a change in appetite.
That was perfect. It appears the rate of appetite loss on Prevnar has changed or is different. I like either of those. Yeah, it appears it's different. What's the matter, Linda?
I don't know how you know that.
Because, hey, let's make it procedural then. How did Emily know it appears it changed? Back up one step. Jolene, the p-value was small. When the p-value is small, which one of these do you believe? Which hypothesis? When it's small, you believe this. When a small p-value, you believe this. Why is it a small p-value you believe this? I'll give you two answers. One is the traditional answer. With a small p-value, you reject the null hypothesis, which means you can't look at this one. Well, if you can't look at this one, that means you better look at the other one. That's one answer. That's the traditional answer. I got no problem with division. However, it doesn't help explaining it to your neighbor, like Emily just did perfectly. So, a better way to say it is, okay, we got a small p-value, right? P-value, if you will, is the percentage of agreement between your data and the null curve. If your data agreed with this curve, wouldn't you get a big p-value for lots of agreement? Right, if you got a big p-value, it would mean you landed somewhere in here, correct? Somewhere in here? Yes, somewhere in here. But you didn't. You got a small one, which means you landed out to the fringes of that curve. Yes, out to the fringes. If you're out to the fringes of that curve, it's hard to believe that you're actually on that curve. You're more likely on a different curve. The different curve meaning different appetite loss than Prevnar. Hold that thought. Hold that thought. I want to get to it. I promise. I promise.
You said different appetite loss than Prevnar, but you meant different appetite loss.
Oh, than a competing medicine. I'm sorry. Yes. Different appetite loss than competing medicine. Thank you, Veronica, for catching that. Thank you. Get my nouns mixed up. Now, one last conclusion, and I want to hit something that Melanie just said that's extraordinarily important, and Eurydice got a question too. I want to get them both. Could we be wrong?
Yes.
Always. Always possibility of being wrong, whether type 1 or type 2. Which one could we have made here? It's a type 1. Why? Why is this one type 1? Because we said there's a change, which means it's a positive test. We said something changed. That could be a false positive, which is a type 1, yes. That could be a type 1 error, because you got a small p-value. Your vote with a small p-value, your vote is you are not on this curve. It appears we're different, yes? That means you're saying a positive test boots you off of that curve. You could be wrong. It could be a false positive, type 1. Melanie asked a very good question. I want you to think about this. She's like, I'm having a hard time wrapping my head around. She gets the 2.7621 being out here. She gets this. She understands this shade right here. She's having a hard time wrapping her head, and this is perfectly fine. I love this, by the way. Why would you also shade down here? That's a great question, and it's not intuitively obvious right now. The reason you're shading both ways is your data was extreme to this direction. If you're trying to see if it's different, though, and you're assigning random chance to it, it's just as possible that it could have been extreme in the other direction as well. It didn't happen this way in this particular case. But if you're testing two tails, You have to allow for the possibility of extreme in either direction. That's why it's doubled. It's not intuitively tied to your data. It's you set it up before the test is even run. That's why it's intuitively a little bit disconnected with intuition. You set that region up before you even collect the data and test it. That's why it's different.
I thought you told somebody that you could put plus or minus in.
You can, but that only because it's allowing for both of those possibilities. Your data comes back either plus or minus, right? Your test statistic comes back as plus or minus. The reason the plus or minus isn't used in the research is because the fact that it's positive does tell you something. It tells you that it's to the right. If you put plus or minus, you kind of occlude that. But if you put plus or minus, it also makes peace with your mind about why there are two regions. It's not intuitively obvious. I'm not trying to say that it is. I'm saying that it's okay that you're wrestling with it. Just realize when you run a two-tailed test, you're going to have two tails. You're going to have this one and this one. It might not make sense with your data, because your data clearly is to the right. It's okay to wrestle with that. It's okay. It's okay not to be perfectly sensible right now. Go, Danielle, and then you're going to question too.
Since the data is all the way to the right,
Yes,
does
ma'am.
that mean there's more
Yes.
incidents?
Because, and this is a good follow-up to your question. So what Danielle just pointed out is, wait a minute, this seems kind of dumb. We've now run the test, and our data fell all the way out here to the right, yes? What you can now do, if you want to as a researcher, is say, let's go back, now we know where it looks like it landed, and run a second test, but make it not does not equals, make it greater than. And it'll still be significant, won't it? It'll still be significant because then it'll just eradicate that possibility.
Because you said it landed on both sides.
You're getting 3 steps ahead of me. What I'm saying is, when you start this research, you have no idea where it's going to land. So you make it two tails to allow it to land in either spot for unusual, unusual up or unusual down. Then, the problem is a temporal one. The problem that's throwing everybody off is it's temporal. When the data comes in, when I hand you this data sheet, it makes it look like all this happens at the same time. It doesn't. You have a theory. You develop a drug, Prevnar. It's designed to fight meningitis. And then you're like, oh crap, it might have an appetite loss problem too. So you set up, let's see if it changes appetite loss. So that's when you set your two tails up. Then you collect the data years later probably, throw it through the ringer, and see where it lands. It's either going to land in one of 3 places. The far left tail, the middle hump, or the far right tail. The two-tailed test allows it to land in one of 2 areas.
But we're not assigning any value to the shaded area on the left?
No, it's only there by definition of where this one happened to have landed. Much in the same way, if this one came back at negative 2.7, it would have landed down here, and we'd shade out the positive 2.7 as well. It's just,
That's what I'm struggling with, is that there's no value over there.
I know, and it's not uber logical.
Yeah.
It's not uber logical, but it's all it's doing, it's a temporal disconnect, Mel, in that you're allowing for it to be extreme on both sides versus just one.
But it didn't, it landed down.
Right, you're just allowing for the possibility for it to land in either side.
I think I was gonna.
Hold that thought, hold that thought, hold that thought. You already had a question before. Did it get answered? It's not uber, it's not as clear as everything else is, because this magical tail just kind of appears down the other end. But the reason is because you're allowing for it to land in both places. I'm not saying that, and Danielle pointed out correctly, you can then retest it, because once you know where it then lands, it's almost like refining your guess. Then you can be like, oh, let's test it over here then. And you can totally do that. Please, Steph, yes?
So is solidfication or p-hat, or is that not the case?
P-hat would be whatever percentage is attached to it. So just so you know, P-hat would just be 121 divided by 7/10. So we can get that real quick.
I think it's 7% or something.
There we go. There, that's P-hat.
So is that 17?
This is 13.5%, this is 17%. Yes, ma'am. Although very often they won't tell you that. They'll just give you the p-value and say here, and then like, well, what percentage did the kids get sick? If you need that, you just go and divide. Like, oh, 17% of them got sick. That's 1 in 6 kids. 1 in 6 versus basically 1 in 7, which is what 13.5% is. So you're picking up one more appetite lost kid per 7, which sounds significant. Two-tailed tests aren't inherently as obvious as one-tailed tests. I'm not saying they are. I had to wrestle with this one for a while too until it kind of clicked in, and then finally it was kind of almost like an admission, like, okay, I see what their point is.
Yeah.
It makes it harder to believe a research hypothesis because you have double the area you're playing with. So that's what eventually you'll come to peace with it too.
This isn't
I'll tell you what, I didn't want to keep you over. I kept you over a couple minutes. Thank you for the awesome questions today. Try this for next time if you have time. If you have time, look at the next data set and try to run the test for it. Try it! We'll do it together, but give it a shot ahead of time and see. The one about the Gainesville motorbike death rate. Give it a shot. Or don't. If you don't want to, that's fine too. I've been trying to why. That's why. You got old flats on, brother, man. So now we'll work this one. It had nothing to do with what you're putting in, it had everything to do with what was already turned on.
Because the value is.
Yeah. Beautiful. Your plot 1 and plot 2 is playing from a data that was there. As I said, it didn't mismatch or something like that. Just make sure your plots are turned on in general. Cool?
Hey, Lola, Jolene was asking me about the quizzes, so maybe you two want to get together and work on those, because since I didn't.
Sure. Take care of yourself. You ready? You sure your question got answered?
I'm going over to that tutoring center right now. I'm gonna go work on my quiz and
Right.
one sheet that I missed. and-
So under, oh my goodness, I'm so sorry. Under a given assumption, if the probability is low,
Yeah, it's like.
it's at 0.05, then the given assumption is most likely wrong. Basically, yeah. Although don't hear Don or anybody else use that word except, they'll freak out on you. I caught hell for that one. You can't say accept, I'm like, I just can't accept.
Yeah.
She's like, God damn it, you can't say
There's
that.
a
We got this like statistical
possibility.
fist fight,
Yeah.
we got this statistical fist fight, I'm like, why not accept? What's the opposite of reject? Accept! And then it just turned into this shit show.
More kids are sick, right?
That's, more kids lost their appetite, which is by definition of getting sick. Mel, I promise it'll start clicking, I swear to God it will, I promise.
Yeah, I was just fine.
It's the change, the 0.005. So it's it's this area. So in other words, it's the likelihood that the kids really are only getting sick at 13.5%, but we got this ridiculously extreme data. So we can say that the average is still 13.5%. We can say it hasn't changed, but the chance of it not changed is 0.005, which is so less than 1%. It's most likely not changing.
I thought that if it's not changing, it would go on the left side.
Not changing would be in the middle.
Okay.
Would be in the middle.
So what I was taking with the 2.7 is I was using that like a standard deviation.
That's our conclusion was. Here's the change.
And I was doing this plus or minus.
Yes, because in the extremes. Exactly. That's what you need to think about. Just think about whether it's in the hump or in the extremes. It doesn't matter if it's 2 or 1 tails. If it's in extremes, it's changing. If it's a hump, it hasn't changed. Keep that ahead of you the entire time. Boom.
I'm just
Boom.
confused.
Don't worry, we'll clear the confusion up.
Are you
I promise.
Does 2.5% play into this at all?
It does. It does.
Will I hear that soon?
Well,
Yeah.
that's what I want to hear too.
That's
Well, it's already there.
Now we're using.
Right. It's already there, right?
Uh-huh.
It's just here. Well, it's just a different color. So here's 2.5% and here's 2.5%.
Okay.
2.5% over
And so
here.
that's fine.
And you see where it landed? It landed way out in the 2.5.
So now, that's why we have to shade both sides to get the 5%.
Because by definition, it's a confidence interval. It's a
Okay.
two-tailed
Yeah.
test, aka a
Okay,
confidence
So we're
interval.
moving her at 95, so on one tail test.
Yes.
here,
Yes.
Yeah.
Yes. Yes.
Oh, it's too bad, what's her name, Melanie left. and
That's
didn't-
okay. You can remind us on Thursday.
That clears it up a lot.
Exactly. I think two-tailed tests are great, except sometimes they get annoying, right? They get annoying.
Well, and I think what was confusing is you said that could be plus or minus.
That's what I'm.
Well, that's what Jolene said. Can I write plus or minus? Absolutely. Of course you can. It's just that the data came back plus.
Yeah, so I don't think we should be able to write plus or minus because the
Because
data
that's where-
says plus.
Right.
Totally. Totally.
Why is this as a standard
Absolutely.
deviation and I did plus here, minus here, and then I got 10 something over here, 16 something over here, and that's where I kept going. How do you know?
Wait, 10 over there. Oh, you were actually adding the percentages.
I was doing I took this and minus the 2.
17, so you got 2.5,
And then
3.5%,
16, and then I'm
3.5%.
like, well, how would you know that this would be the one you would use and not the?
Because it's what happened. The question is, how do you justify the second tail? that's where the plus or minus it actually is there mathematically. The plus or minus is there.
Even when you get your result?
No. Careful.
The
It's apples,
potential.
oranges. Apples,
Yes.
oranges, right?
So-
You
so
have to
that's-
have both
We're gonna
tails.
talk about it Thursday.
We're gonna talk about it constantly.
That's what's confusing,
I
because
know.
there's a potential to
Anyways,
have
let's-
both.
Yeah.
No, Jolene, do not be sorry. Do not be sorry. What you've opened up is a beautiful can of worms.
Yeah.
The can of worms you opened up is, and you're correct, Veronica, when